Today we are going to do increasing decreasing function. For that, first I want to show you GeoGebra graph. I have taken a function of your book, and this is 2x cube minus 3x square minus 36x plus 7. When I have plotted this graph on GeoGebra, the graph is coming like this. There are two turning points. One is here and one is here. So I have taken the tangent. I have taken the tangent of the curve, and I am moving this point throughout the function. Okay. Now, the slope is visible over here. M is equal to 88.95. As I am moving this up, point is going A, the slope is remain positive. Slope remains positive. But as soon as this A turns the side, tangent parallel to x-axis and then comes down, the slope is now negative minus 8.18. Means when dy by dx is when dy by dx is sign is negative, then it is decreasing, and when it is positive, the function is increasing. Based on this, we are going to attempt the questions of the exercise. So let us come to the exercise 6.2. What is increasing function? Increasing function is this, directly, strictly increasing. But this is increasing function. Here at any 2 points, the value can be same. But in the strictly increasing function, no 2 points have the same value. This is strictly increasing, this is increasing. Same is for the decreasing. Strictly decreasing, at no 2 points the value is same. But strictly decreasing is, it might be possible that at 2 points, one of the value is same. So this is the difference between strictly increasing and increasing. And when dy by dx sign is positive, then function is increasing. And if this is minus, then in that interval, function is decreasing. So based on that, let us try to attempt exercise. Question number 1. F of x is 3x plus 17. We have to show that it is increasing on R. So f dash x, that is equal to 3. 3 is positive always. It will not change its sign. It's a constant value. So what will we say? F of x is increasing throughout on R. Okay. It is increasing all the time on R. Second question. F of x is e raised to power 2x. We have to again show this is strictly increasing on R. So f dash x is 2 e raised to power 2x. Now, e is a function which is always positive, even if it is a raised to power minus 1. So, it will become 1 by e, and e value remains in between 2 and 3. So, this is e, whatever the power of this is negative, positive, or whatever is the power, it will remain positive. So, what will I say? As e is always positive, therefore, f dash x is always positive. Therefore, it is increasing on R. Third question is, f of x is equal to sin x. So, f dash x will be cos x. Now, cos x, 0 value is 1. F cos 0 is 1. And it is always positive in the first quadrant, 0 to pi by 2. In first quadrant, cos value is always 1. 0 to pi by 2. Cos is always positive. So what will we say? The function is increasing in the interval 0 to pi by 2. And in the second quadrant, cos is negative. Second quadrant, cos is negative. Therefore, function is decreasing in the interval pi by 2 to pi. Now, remember, if a function is increasing in one interval and decreasing in one interval, again increasing, it's a cyclic function, then, or periodic function, then you will say it is neither increasing nor decreasing. Clear? Because there is no trend of continuous increase or a continuous decrease. Clear? So next question 4. F of x is 2x square minus 3x. What will be f dash x? That is 4x minus 3. So if I make f dash x is equal to 0 to find the critical point, x will become 3 by 4. Now we will do this question by wavy curve method. So draw the line. If turning point is 3 by 4, this side is minus infinity, this side is plus infinity. Now, for the rule of this, remember, let me explain the rule of wavy curve. Whenever you have a wavy curve method, you have to find the zeros of f dash x. When f dash x is 0 means the tangent is parallel to x-axis. Or at those points, suppose I have x minus 1, x minus 2, x minus 3 is equal to 0. So the points are 1, 2, 3, right? This side negative infinity, this side positive infinity. So what will you do? You will start positive from the right side of from the positive infinity, you will take plus sign, then alternate sign. When the power of these factors is odd, x minus 1 power is odd, x minus 2 power is odd, x minus 3 power is odd, you will take alternate signs. You will start from the right side of this plus infinity side and start marking it positive, negative, if the powers are odd. But suppose here x minus 2 is square or 4, even power, then what will we do? At 3, the power x minus 3, power is 1, so this is plus and this side is minus. At 2, this is this factor, so power is 2. So whatever is the sign over here, I'll take the same sign over here. At even power, both the sign remains same. Okay, then at x minus 1, power is again 1, so here it is negative, so it will become positive over here. Again, listen to this. When the powers are odd, we take alternate sign. Alternate signs. But if the power is even, then both sides the sign remains same. So if I make it square over here, it will become plus, so this is also plus. If this is plus and sign x minus 2 is also, so this will also be plus. And this side now will become minus. Why? Because x minus 1 is odd power. So 1 minus 1 to infinity, this is negative sign. Okay? Just a minute. So is the signs clear to you? For trigonometric functions, we do the otherwise. For trigonometric function, the interval most of the times are given to you, and that way we will start from this side is minus infinity, this side is plus infinity, but intervals are always given, and we start from the left side. Suppose the interval is 0 to pi by 4, pi by 2, and pi, then it's always positive, negative, and square and all of the sign. This rule is same over here also. And when the question will come, I'll explain it. Okay. And one more thing I want to show you. See, if the f dash x after this, there is a minus out. Suppose the minus common is out, and then you have made the factors, then it will be first minus, then plus, then minus, and then plus. It will be alternate this way. Means when here it is plus, you will start with plus. And here if it is minus, you will start with minus. Clear? So let us come to the questions. Now, as the power factor is 1, so it is plus, this is minus. So this is decreasing in the interval minus infinity to 3 by 4 and increasing in the interval 3 by 4 to infinity. Clear? Then next function which I have just shown you on the GeoGebra, f of x, that is equal to 2x cube minus 3x square minus 36x plus 7. So f dash x is 6x square minus 6x minus 36. So 6 is common. X square minus x minus 6. So if I make the factors of this is x square minus 3x plus 2x minus 6. So what will be the factor? X minus 3 and x plus 2, right? So if I make f dash x is equal to 0, what are the points? The turning points. X is equal to minus 2 and 3, right? So now draw the line. Minus infinity plus infinity. This is minus 2, this is 3, this is, now check. This is positive sign over here. So I would start with positive. What is the power over here? X minus 3 power 1 now. So it will be alternate over here. Then x minus 2 power 1 now. So it is alternate over here. So what will we write? Now remember at the last you have to make a table over here to complete the question. Here first you will write interval, then sign of f dash x, then nature of fx. This will be your final table. Without this, you will not get any marks. So, you will not get full marks. Minus infinity to minus 2. What is the sign? Positive. F of x is increasing. Then minus 2 to 3. Sign is negative. So, this is decreasing. And then 3 to infinity. It is positive. The f of x is increasing. This is you have to write, make as a table. Then final statement, function f of x is increasing in the interval, minus infinity to minus 2, union 3 to infinity, and decreasing in the interval minus 2 to 3. Clear? So this is your way of completing the question. You have to write full statements over it. Now come to question number 6, first part. Let me do second part, B part, because I have to take negative common over here. Then it will be clear how we will start with negative. 10 minus 6x minus 2x squared. So f dash x is minus 6 minus 4x. So if I take the common will be minus, so 4x plus 6, right? So f dash x if I make 0, so it will be 4x plus 6 is equal to 0. So x is equal to minus 3 by 2. So if I draw the line over here, minus 3 by 2, minus infinity plus infinity. Now, if you check, the minus is common over here. So I'll start minus over here, plus over here. This is the rule for this. If the f dash x is giving you minus in common, then you have to start with negative, positive, and alternate like that only, or repeat according to the rules. Okay. So minus infinity to minus 3 by 2, this is strictly increasing, and minus 3 by 2 to infinity, it is strictly increasing. Clear? Next, C part. F of x is minus 2x cube minus 9x square minus 12x plus 1. So this is f dash x, that is equal to minus 6x square minus 18x plus minus 12. So again minus 6 is common, so x square plus 3x plus 2. So the factors are minus 6, x plus 1 and x plus 2 and 1. So x plus 2, right? So if I make f dash x is equal to 0, then x is equal to minus 1 and minus 2. So let us come to the line now. Minus infinity, plus infinity, minus 2, minus 1. Here as again the minus is there in f dash x taken common. So I'll start with minus. Now at this power x plus 1 power is odd, so it will be alternate. Then x plus 2 power is odd, so again this is alternate. So this is decreasing in the interval minus infinity to minus, strictly decreasing in the interval minus infinity to minus 2 and minus 1 to infinity. And then the increasing in the interval minus 2 to minus 1. Clear? You have to make that table. Now I'll want to show you E part also. E part is f of x. How to do the calculation for this type of question? X plus 1 cube, x minus 3 cube. Don't multiply and open the cube and all. Just keep as it is. F dash x is first function as it is. Derivative of second function plus second function as it is, derivative of first function, right? Now if you see x plus 1 whole square and x minus 3 whole square is common and 3 is also common, so I have taken it out. What is left inside? 1 power, here it is 3, I have taken 2, so x plus 1 is left over here. Here it is x minus 3 square and here it is x minus 3 cube, so plus x minus 3, right? So I am getting 3 into x plus 1 square, x minus 3 square, 2x minus 2. If you take common 2, so it will become 6x plus 1 square, x minus 3 square, x minus 1. So if I make f dash x is equal to 0, what will you get? From here, x is equal to minus 1. From here, x is equal to 1 and 3. So you are getting 3 where the dy by dx will be 0. Means tangent is parallel to x-axis. 3 points are there. So let us draw this curve. Now, minus 1, 1 and 3. Outside is positive. So this side I'll start with plus. Now, at 3, what is the sign over there? Even. So at 3, if the right side is positive, this side will also be positive. At 1, x minus 1, this is giving me 1 now. Power is odd. So if it is plus over here, this will be minus over here. Now at x minus 1 point, this is x plus 1. Power is even, so the sign will remain same, but this side is also negative. So what will you say? The function is strictly decreasing in the interval minus infinity to minus 1 union minus 1 to 1 and increasing in the interval 1 to 3 union 3 to infinity. Clear? Is this clear? Don't simplify the things over here by opening or something. Don't multiply them. Just take common square and then you will get the zeros very easily. Now, the question 7 and 9 are important. Just check how to do these questions. Question number 7 is y is equal to log 1 plus x minus 2x upon 2 plus x. X is greater than minus 1. Is increasing function of x throughout its domain. What is the domain? X is greater than minus 1 is the domain of this. Clear? Domain is mentioned over there. So let us start. Dy by dx is log will bring it down. So, and this is by u by v method. So 2 plus x whole square. Two plus x as it is. Derivative of 2x is 2 minus 2x as it is. Derivative of 2 plus x is 1. So I am getting 1 upon 1 plus x minus 4 plus 2x minus 2x upon 2 plus x whole square. So minus 2x plus 2x cancel. So I am getting 1 upon 1 plus x minus 4 into 2 plus x whole square. right? So if I take the LCM over here, one plus x into 2 plus x whole square. That will give me 2 plus x over here and minus 4 into 1 plus x over here. So I am getting 4 plus x square plus 4x, 2x, 4x minus 4 minus 4x upon 1 plus x and 2 plus x square. So I am getting final as after calculating all my cancellations. This is I am getting, right? This is your final f dash x, dy by dx after calculation. Now, in this, we will not find out zeros. What will we do? We know that the square of a number is always positive. So, what we will say as x square and x plus 2 square whole square is always positive, being square numbers, being square. So, function is increasing when f dash x is positive. Now, this is positive, this is positive. So, what we have to check? X plus 1. So, f dash x is positive when x plus 1 is positive. Because this is positive, this is positive, this is negative, then it will become negative. So, we have to make this positive. So, we have written f dash x will be positive when x. So, x is greater than minus 1. So, f dash x is greater than 0 when x is greater than minus 1. So, can't we say that f of x is increasing in the domain is increasing in domain x greater than minus 1. Clear? Remember, whenever in increasing and decreasing, you get square. Don't discuss them. You can directly write being square, they are positive. Discuss the other terms. Clear? We can do in those wavy curve question also. But here, this question is more easy this way. Next. Question number 9. I am doing 8. You can try. Ninth question is y is equal to 4 sine theta upon 2 plus cos theta minus theta. Now, this is trigonometric function and interval given is 0 to pi by 2 closed function, right? They have mentioned it closed. So, let us find out dy by d theta. So, this will be u by v method 2 plus cos theta whole square 2 plus cos theta as it is. This is 4 cos theta. 4 sin theta derivative is 4 cos theta minus 4 sin theta as it is. Derivative of 2 plus cos theta is minus sin theta because 2 is 0, cos theta is minus sin theta and minus theta is minus 1. So this is I am getting as 8 cos theta plus 4 cos square theta plus 4 sin square theta upon 2 plus cos theta whole square minus 1. Now, if I take 4 common from here, cos square plus sin square theta is 1 now. So, it is 8 cos theta plus 4. I am taking the LCM now. Minus 2 plus cos theta whole square upon 2 plus cos theta whole square. So, if I open this, I'll get 8 cos theta plus 4 minus 4 minus cos square theta minus 4 cos theta upon 2 plus cos theta whole square, right? So this plus 4 minus 4 cancel. 8 cos theta minus 4 cos theta is 4 cos theta minus cos square theta upon 2 plus cos theta whole square. Now, if I take cos theta common, so this is 4 minus cos theta upon 2 plus cos theta whole square. Now, what will you do? 2 plus cos theta whole square is even, sorry, positive. Positive, not even, sorry. It's positive, being square. 2 plus cos theta whole square is always positive. Now, if I find out cos theta lies between minus 1 and 1. We want to check whether it is positive or negative. Don't make it positive and say cos theta can't be 4, so rejecting this value. No. So, for cos theta lies between minus 1 and 1. Minus cos theta will lie between. Inequality will change when we multiply with minus or divide by minus. Now, I have to make it 4 minus cos theta. So, add 4 to all the three. So, this is 4 plus 1. This will be 4 minus 1. So, I am getting 4 minus cos theta. That lies between 5 and 3. Na? Check. This value is between 3 and 5. So, 4 minus cos theta is also positive as it lies between 3 and 5. So, f dash x is positive now when cos theta is positive. Right now, we are saying function is increasing when derivative sign is positive. So, we have checked that this 2 plus cos theta whole square is positive. Then 4 minus cos theta lies between 3 and 5. So, this is also positive. So, f dash x is positive when cos theta is positive. That is the third factor over there. Na? See, this is cos theta, 4 minus cos theta. These two terms are positive now. So, the f of x, f dash x sign will depend on this. So, what is this? F dash x cos theta is positive in when theta belongs to 0 to pi by 2. So, that is only we have to show. That is only we have to show. That the function is increasing in the interval 0 to pi by 2. Clear?